All right, everyone. Welcome to another episode of the TWiML AI podcast. I'm your host, Sam Charrington, and today I'm joined by Vidyut Naware, Director of AI and Machine Learning at PayPal. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Vidyut, welcome to the podcast.
Thanks, Sam. Happy to be here. Big fan of your show.
Thanks so much. I'm really looking forward to this conversation and learning a bit more about what you're up to, both from the perspective of the hat you wear, leading applied ML and AI at PayPal, but also some of the work you're doing supporting MLOps and the machine learning platform teams there. But before we jump into all that, I'd love to have you share a little bit about your background and how you came to work in the field.
I joined PayPal 3 years ago. And I was, before that, I used to work in the autonomous driving area. I used to work at a company called NEO, where my team was working on building kind of very interesting anomaly detection algorithms for catching crazy driving scenarios out there in the field. Before that, I used to work at Qualcomm, where I led several interesting projects in modem design, sensor system design, and so on. That's where I started getting my hands and feet wet with AIML, if you will. For the past 3 years, I've been at PayPal, where I'm leading, as you said, the AI R&D function, applied AI R&D function, and in addition, of late, I've also started leading some of our MLOps efforts in this area. So, really, interested in sharing what we found in our journey so far.
Awesome. Awesome. Just thinking about some of the places you've been on your personal journey, you kind of started out in these very, edge scenarios, hardware driven scenarios. And I'm imagining that PayPal is not like that at all. I'd love to hear you kind of compare and contrast some of your prior experiences to what you see now in PayPal.
Yeah, that's a great question. Actually, as you rightly pointed out, when when I was at Qualcomm, it's a very different vertical, very different space, and the kinds of problems that you encounter there, have more to do with having very, very limited access to compute, limited access to memory. So the focus there entirely is on how do you kind of build the most, energy efficient algorithms from an AI/ML perspective, versus when you move into a company like PayPal, which is primarily kind of like a cloud-based, platform. It's a very different situation altogether. I mean, you're no longer strictly limited by the amount of compute, memory, resources you have. It becomes a slightly different environment where you are trying to, bring AI/ML to production. So, um, just as an example, right? Like, when at Qualcomm, when we were building, various algorithms, in the sensor area, right? So this is where we are trying to use accels and gyros, to figure out whether what kind of activity a person is engaged with sensors. We have a very, very small power budget, energy budget to work with, so we really, really have to focus on making our algorithms very, very efficient. In PayPal, it's kind of like a different. I think here it's more about how do we, um, you know, uh, make sure that we are deploying the algorithm to solve, to improve performance. But cost is a consideration, but it's not the most important thing, right? So it's an interesting, set of experiences I've had. And then autonomous driving, kind of that area falls somewhere in the middle of both of this, because on the one hand, you're still doing all of your inferencing on the edge, because ultimately all your computer vision processing has to happen on the car. But so in that sense, it is energy constrained, because you have to do all of that in a kind of battery constrained environment. But on the flip side, the performance that you need, the bar that you need, is very high. And also, um, the complexity is extremely high, right? Because you're processing very, very high bitrate video streams from multiple cameras concurrently, right? So the amount of compute you need to solve those problems is much higher than what I was dealing with when I was at Qualcomm, for example. So it's just like each area has had its own difficulties and challenges to deal with, but it's also made me aware of very very interesting perspectives on solving the same problem.
And I think about again, financial services or PayPal in particular. Fraud is probably the first thing that jumps to mind for me and for other folks. What are some of the other use cases that kind of fall in your portfolio and that are important at PayPal?
Yeah, it's a good segue into kind of what overall data science at PayPal looks like. Before going there, maybe I'll just spend a few minutes talking a little bit about PayPal, right? Like what we do, and where we are at in terms of scale and so on. So as you know, PayPal is probably one of the most widely recognized kind of payment services company. We have, at last count, maybe around 395 or so million customers, maybe another 30 to 35 million merchants on the platform. So basically what we enable is this two-sided network where we have, on the one hand, all these customers who can use PayPal products to move money, to manage money. We also offer credit services to customers, for example. And then on the merchant side of the house, we have our checkout product. We have several other. We have a whole laundry of products, right, where we enable our merchants to improve their own metrics, their own business metrics. We also help them with risk and fraud management, for example. And last but not least, we also provide merchants with credit, right? So as and when they need it. Also, not to forget, but it's probably not widely known, probably, to your audience, but Venmo, Zoom, they are also actually PayPal products. Very very popular. For example, Venmo with Gen Z, and Zoom is
Zoom for
obvious,
cross border.
cross border remittances, right? Like super
Zoom
popular.
with an X, not Zoom with
Zoom
a
with an
Z.
X, exactly. And several more, right? Braintree, for example, which is a payment gateway
Recurring
solution we offered.
payments.
Yeah, which
Hmm.
not just recurring payment, but basically it's a payment gateway for merchants, right? Similar to what Stripe offers to merchants. Anyway, so I think the first thing to understand is PayPal is a very diverse ecosystem with a lot of different services and products. And each one of them have their own, I would say, flavor of AI/ML embedded within them. But again, just zooming out, if I were to broadly categorize all of the AI/ML, I think, driven products, I think the number one would be definitely fraud prevention. That is the area where we have the most advanced, most complex AI systems in use and deployed. um, After that, there is credit. So several of our credit product also is powered by AIML, in especially in the underwriting process, in the marketing of those kinds of products to prospective customers or merchants. Then there is things like sales and marketing. When we are trying to essentially cross sell or upsell, our existing products to an existing customer or merchant, we will typically try to use ML to identify those customers who are most likely to, basically propensity models, which will help our business teams to identify the best set of next customers to target on the both sales and marketing side. There's also customer service, right? So we at the in our PayPal is a big company, right? And many people reach out to us whenever they have some issue with a transaction that didn't go through, or a transaction that was put on hold, or stuff like that. So people contact us a lot of the time. We actually use NLP, BERT like models, in many of these use cases to identify, for example, in a chat context, the intent with which potentially a customer is calling us or contacting us. And then there is compliance. So again, this is where the regulatory side comes into the picture. So we are expected to catch any kind of illegal activity on the platform, things like money laundering or drug trafficking and so on. Like, there are all these kinds of use cases that we are supposed to catch and flag to regulatory bodies. So we again use AIML there as well, because ultimately, if you map all of some of these problems, they all become AIML problems at some level. Um, and again, this is just I would say the probably the top 5 or 6 use cases, but there is many many. I would say there's again kind of like a longish tail of other areas within PayPal where there's a lot of exploration going on around where AML can be used um, to solve a certain business problem and so on. So hopefully that gives you a full view of what AML looks like at PayPal today.
No, that does. And now, if you could then kind of use that as a segue to map to your applied R&D portfolio, and you think about the projects and investments you're making there, and what you think is most promising for the sets of problems that you have in terms of approaches.
It's a great question. So I'll probably provide my perspective on how I look overall at kind of the area of R and D, wearing the PayPal directory and R and D hat, right? So for me, like the overall AIML landscape, like I break it into four categories. There's kind of like the hardware compute layer, where I feel there's a lot of innovation happening. Then there's the core algorithmic layer, which is kind of the focus of most of the academia, and the Facebooks and Googles of the world. And finally, there's the application layer, right, where a customer is interacting with the product, and he gets some experience driven by AI, right? So each of these areas, I feel there's a lot of innovation happening, and so my role as
And
an
did you
R&D
say
lead,
four?
yeah, sorry, fourth one is tools, frameworks, and platforms, right? So
Got it. I thought you were going there, but just to
yeah,
confirm.
I missed it. Sorry. Thanks for catching it. So the tools, frameworks, and platforms are, this is where I look at the overall ecosystem, right? And this is where, for example, MLOps enters the picture, right? So how do we make sure that not just each cog in this wheel is doing well, but as a whole, how does everything kind of work well together in the most efficient manner, right? So MLOps, things like interoperability platforms, because there are all these different machine learning frameworks. There's TensorFlow, there's PyTorch. Now, how do we actually Onyx? Yeah, how do we? Yeah, so Onyx is, for example, something that we are investigating for our use cases. So now let me kind of like you know kind of like dive deeper into three main, like I would say, areas of R&D, right? The first is the kind of hardware compute layer. um, Here I think of two primary initiatives where we are already made some investments. We are really hopeful about what where this is going to go. The first one is this whole idea of federated learning, and how do we essentially benefit from being able to offload some of our inferencing and hopefully in the future training workloads, right, directly to the customer or merchant devices, right? So we have some ongoing work in this area where we feel it's the right time. It's going to be very important from a cost management perspective, also from a privacy and regulatory perspective, that the closer we move the compute, and the lesser we move data to our data centers, the I think the better it is for everybody in the ecosystem. The second one is around how, again, this is something that we are uh, extremely positive about, which is how do we um, essentially make sure that we use um, uh, the data that we use, right, fundamentally at the data layer, at the compute layer, in the most efficient manner. And For example, this could be things like, how do we, for example, store data at 16-bit resolution? Do we really need to store data at 32-bit resolution? Do we really need to do compute at 32-bit? Can we do it at 16-bit? Because again, the impact the impact that this has on the overall cost of building an AIML solution, and especially for a company like PayPal, where we have such humongous amounts of data and to deal with, right? So we are investing in this area as well. Like, how do we optimize our compute layer? How do we optimize our data layer? Um, and then So those two, I think, are the kind of, I would say, primary two things we are focusing on. um, yeah, the hardware silo, we have, for example, done some pilots in the quantum computing area. We're also looking at, for example, in the area of graph compute, right? What is the best possible hardware layer for graph, because as you know, graph computing, I think the underlying hardware ecosystem today is not optimized for graph, because of the fact that the memory access patterns when you're basically trying to do graph compute are um, are not well suited to today's, I would say, computer architecture. In this particular instance, for example, we are um, uh, working with some external partners, trying to understand where this might go. But there's several different lines of things at the hardware acceleration layer that we're also considering.
So, kind of in this the context of hardware, you're looking at federated learning. I'm curious, when you think about federated learning, are most of your efforts focused on what I think of as kind of the algorithmic elements of federated learning, like differential privacy and privacy preserving machine learning, or more like deployment challenges, logistical challenges of just getting models, model slash data to and from devices and coordinating all of that, distributed training, things like that.
Yeah, so it's a journey for us, Sam. And federated learning, has many components, pieces. Some of them, as you said, more AI ML algorithmic in nature. Some of them more engineering and infrastructure oriented. So in terms of our journey right now, we are focusing on first. It's kind of like crawl first, then walk, then run. Right. So the first goal is start to actually do inferencing of some models, on the device. um, Gradually, as in parallel, of course, as you said, it just doesn't stop there. We have to start thinking about differential privacy. Can we, how do we make our models differentially private? uh, that's one angle to it. Federated learning, where the full ambit of federated learning actually is also eventually doing training on device. um, but I think that's a bit far out from our current from where we are right now. But it's certainly things, there are opportunities here to do that. I would just say that that's where we are at, basically, in this particular area.
And then you mentioned a couple of the kind of accelerated hardware acceleration um, opportunities that are out there. Is there anything in particular that you're finding exciting or interesting among the things that you've been looking at?
I would say there are definitely interesting things, but I feel they're a bit, like, from an overall technology maturity standpoint, I think they're not quite there for prime time. For example, our recent work on quantum computing. Let me just share some context, right? We um, One of the steps in basically the AML workflow is feature engineering, and one of the sub steps there is feature selection, right? So let's say you have a catalog of features and you're trying to find the best possible subset of features for a given ML problem. um, that problem is fundamentally a combinatorial optimization problem. With the complexity of the number of features that we have, yeah, today we use greedy approaches, traditional classical greedy approaches. So one of the POCs we did on quantum was, and this was with some external vendors like IBM and D-Wave in this space. And what we found is, that we didn't get exactly very, very conclusive results that demonstrated that the feature selection that you can get with kind of like today's quantum computers can actually you know outdo classical approaches yet, right? So um, um, so that was a, like a sobering, uh, you know uh, I guess, a revelation for us. And we feel, okay, so there's a few more years for this particular area to evolve, right? That's a specific case in point, but I feel that's a kind of broader industry trend. Like, I know there's a lot of startups right now in overall the hardware acceleration space. uh, you know uh, Companies are building custom silicon to accelerate AI workloads, either for training or inference. um, um, but we don't yet feel the need to go there yet, but maybe in the future. So that's probably the, I would say, in terms of overall hardware space, that's probably the closest to, from a technology maturity standpoint, custom silicon for AI workloads. But I think that probably is not what we are the most interested in right now.
And I've got to imagine if you're a significant user of cloud computing, you also are to some degree banking on the cloud providers' investments in custom silicon, decreasing your costs and providing better performance. So maybe it's not the thing that you need to spend your efforts focused on.
Spot on again. Absolutely right. I think for, especially for quantum, right, like again as a case in point, I think with quantum, it's a kind of steep learning curve to understand how quantum computing works. And so we actually went ahead a little bit, and because it's a long lead time activity, we decided to do some work by ourselves. But as you said, maybe in a few years time, quantum computing and all these graph, I would say graph and other hardware acceleration silicon might all be abstracted away by cloud providers, and we kind of don't have to worry about all of the early technology maturity issues that otherwise that you face, right, typically when you go down to the hardware layer. So absolutely, yeah.
What was that second area that you mentioned? Was that algorithms?
Yeah, algorithms. Yeah, yeah. So in the algorithms bucket, Sam, I think we have, as you can imagine, the sets of things that we are doing here are should be very familiar to your audience. Things around representation learning, sequence to label learning, transformers. How do we use these in our most complex use cases? So this is one area of focus for my team. Another, I would say, increasing area of focus for the team is, around causal ML, causal inference. Um, um, I think this is there are two primary use cases here. One is many problems that we encounter typically in the marketing area. They are more causal in nature, where you're trying to influence behavior of customers and merchants by taking certain actions. So we believe that instead of looking at these problems as predictive problems, they are much better formulated as treatment and effect kind of problems, right? So we're doing some early research here, partnering with some teams to figure out if there is an improvement in performance by changing our approach to those problems. The other interesting application of causal ML is in what we believe is essentially identifying causal features, right? In going back to that feature selection problem, right? A lot of today's feature selection problems fundamentally are rooted in correlation, right? You're trying to understand how features are correlated with labels. um, but I think with causal ML there are approaches which have actually been shown, where you can try to learn more causative features for why a certain thing might be happening, which in turn helps with making um, our model more robust, right? Because and to our earlier discussion that we were having around the fact that data distribution is drifting, and as the data distribution is drifting, so is the model score, right? But if we can fundamentally identify features which are causal in nature, we expect the model's output to be more robust to this kind of noise, right? So this is another area where we feel causal ML could play a big role, and it should help, for example, with keeping our performance of our model stable over longer periods of time than it is today, for example.
Are there any references you can point us to on the causal features work?
Yeah, there is some prior work done by Professor Susan Athey at Stanford, who actually we had done a pilot with her team back in 2020 on this area. But again, that was one single pilot with one single use case. So we are continuing to explore other areas and other use cases. But the basic idea is, how do you identify causal features using some causal ML techniques. So moving on, maybe to the third area.
I imagine you didn't mention it, but I imagine under algorithms you're looking at various graph machine learning techniques as well.
Absolutely, absolutely. We are looking at graph machine learning. It's a big area of research for us. This is where we are, using GCNs to learn embeddings for several kinds of use cases like collusion detection. Like one form of fraud is collusion, where the buyer and the seller collude to essentially game the system. So in these kinds of use cases, we have found that GCN based embeddings can actually really help improve the performance. To catch this kind of this kind of fraud, but but going beyond that, right? There is graph is such a rich representation of our user interaction data that uh, and couple that with the fact that graph ML itself is evolving so rapidly right now in the academia. There's so many great papers and research is coming out in this area, that it's a continuous area of exploration for us. How do we is evolving really quickly. So we are exploring it in several contexts, be it, fraud detection. We can also um, another use case that comes to mind is compliance, as I said, like, because there are very when you look at how money laundering occurs on a graph, it is almost, you'll immediately see how you can actually use graphs to catch it, right? But the problem with graph, which I was alluding to earlier, is the scale of the graph that we have at PayPal. We have like millions, millions of customers, right? And like billions of transactions happening every year. So to model all of that, to keep that graph up to date, to be able to train models on this kind of evolving graph and so on, it's a very challenging problem. um, so that's one part of it, and then at the algorithmic layer, graph also, as I keep saying, lot of interesting work happening in this area. So we are doing our own pilots in this area.
And just maybe taking a step back, do you think about kind of applied R&D in the context of algorithms as, taking the stuff that the Stanfords and Googles and Facebooks are doing from a research and academic publishing perspective, and trying to understand how they fit into your problem domains? Or are you also doing academic style research into the problems that interest you?
Yeah, I think it's more of the former, in the sense we are an applied R&D group, so we are not focused on kind of fundamental research, I would call it. We are not Our goal is not to uh, let's say come up with novel problems and publish them to conferences and journals. It's definitely an applied R&D function. In terms of how we uh, to rephrase your question, like how do we kind of groom our backlog, right? How do we decide what to work on and what not to work on? It's a combination of things. I think we're definitely monitoring what the Googles and the Facebooks are doing. We are also monitoring conferences, like the top tier conferences like ICML, ICLR, and so on. And trying to, I think the some of the differences that we see from academia, from when you look at everything from an academia lens versus a like a applied R&D lens, is for example, number one, like a lot of AIML research is focused on NLP, CV, unstructured kind of I would say data, versus R is focused on, I would say, some portion of it structured, some portion of it unstructured. um, and uh, I think the other thing is, financial services space. We have our own unique, uh, I would say, attributes to our data sets, which are not like typically found in kind of academic conference, right? So one of the key things that me and my team do is really connecting those dots, right? So you will see a lot of things that show up in CV or in NLP land, but the key is like to identify how do you map let's say the problem and the solution to our domain, right? And to see if there is some potential, right? It sounds very easy to say, but it's actually very hard to do in practice, right? Um, so but I think this is really the key, I would say, role that we play in addition to running the pilots and doing the R&D itself. I think the key part is ideating and understanding what trends are happening in these related but separate domains, and how do we kind of like map it to our domain, right? That is the real secret sauce, I think, to our group and what we do.
So the third area.
Yeah, the third area is kind of more on the applications side, as I mentioned. So this is primarily, this is where I think most of our focus area here is on the responsible AI side. Things around explainability, fairness, privacy, adversarial learning. How do we essentially look at these problems and solve them for our customers, basically ultimately for our customers, but also make sure that we are complying with regulations and laws. And we have a pretty, um, I think in the last year or two, we've actually taken steps at PayPal to make sure that we really are uh, you know building our models in a very responsible manner. We have governance, and I would say processes in place to make sure that as we build models, we are paying close attention to how do we make them explainable, how do we ascertain that they are fair. In some areas, for example, we are already doing it because it's required by law, but we are also now starting to think about all the new areas where we need to start paying attention to all of these things. I already mentioned a little bit about privacy. And then finally, on the security side, we are starting to really look at adversarial learning, as how do we, for example, in a fraud detection context, how do we use adversarial learning to make our models even more robust. Um, so uh, ultimately, I think our customers interact with us through the application layer, and so we really need to make sure that everything that we are doing as a customer sees it is done in a responsible manner, which complies with law and so on. So this is an area that my team is heavily invested in. I would say that would probably be the number one. On the second area here is probably more around the conversational AI side, where we want to build, uh, for example, chatbots, which uh, which basically delight our customers in terms of giving them a very good experience. Um, and uh, uh, so here, there is some R&D happening within my team where we are trying to look at how do we use techniques from reinforcement learning, to essentially train a chatbot with all the previous chat logs that we have of our customers with our agents, for example, right? So that's a very interesting area of research for us as well.
And the fourth area was around tools and MLOps, platform technologies, that kind of thing.
Exactly. So I think that actually is the glue that eventually ties all these three layers on the top. So definitely MLOps, interoperability platforms. How do we make sure that both on the deployment side as well as on the training side, we have an ecosystem that you can train in any framework of your choice, deploy on any kind of device, be it like a phone or a browser, right? So these kinds of things are also, we have various pilots ongoing in this area as well. And then the big one is MLOps, of course, um, which we've been on our own journey, I guess. But this is basically the place where we try to automate as many of the steps involved in model development and delivery, uh, to the extent possible, right? Like that's the ultimate goal. Um, so uh, this helps, as you said, with making our development cycles shorter and basically increasing deployment velocity, right? So this is the primary objective of the MLOps area.
And is MLOps from your perspective, um, is it still applied R&D into MLOps, meaning looking at kind of the, however you characterize the time horizon, hey, what are we going to be doing in MLOps 3 to 5 years from now? And then exploring those things and transitioning them to other internal teams that are focused on, 1 to 3 years? Or does your team, is that MLOps component, like you have all this kind of forward looking stuff and you're also responsible for the platform that your teams use today in production?
It's a great question. I think I would say it's a combination of both. I think there is some part of that team's bandwidth that goes into more forward-looking R&D type of stuff. So connecting back, for example, to our first conversation on unsupervised versus semi-supervised, right, approaches to for fraud detection. So that team, for example, will look into something like that, because ultimately it's a way for us to improve. It's a way for us to automate the process of a model refresh by looking at a technique like semi-supervised learning, right? That's the R&D side. But as you can imagine, this is also a very kind of product and execution heavy function. So I would say 50% of the bandwidth goes in kind of like the day to day building of the pipelines, onboarding new models and customers onto the MLOps rails, and so on. But and actually, this was also, by the way, the reason why this function was synergized with the R&D group, because we already see that there is there's plenty of synergy in terms of the fact that some of the work happening in this group is R&D in nature. And so it just made a lot of sense for me to actually uh, you know basically look at both the R&D side of the house as well as the MLOps R&D side of the house, so that we can even synergize more.
Mm-hmm. Mm-hmm. Well, I feel like we need a whole separate conversation just to dig into the details around your platform and tooling choices and the way you think about automating the machine learning workflow.
I know. we didn't even,
We
we didn't even get to it.
didn't even get to it. That said, it has been wonderful, exploring the way you're thinking about applied research and development at PayPal, and some of the use cases that you're looking at and the things that you're excited about. Even there, it'd be great to go into a lot more detail. So we'll have to make sure to stay in touch and have some follow on conversations.
Thank you, Sam. It was great to be on the show.